My first job was with the Waterways Experiment Station and then ultimately the Mississippi River Commission in Vicksburg, Mississippi, which had the governance, if you will, of the flood control systems down into New Orleans. And so I was very interested as a young engineer in the flood control work that was done there. When Katrina hit, there were a number of issues that arose. Obviously, why did the system perform so poorly? Why were there failures? What lessons could be learned from it? And particularly since the Corps of Engineers knew that it had to be rebuilt, how would it be rebuilt and to what standards? The events surrounding the hurricane and surrounding what happened in New Orleans were exacerbated by not only nature, but also by the failure of the system, the hurricane protection system that was there. And so I was asked to chair a panel, a committee that would be formed. I would give some advice as to who would be on it. That would be a sort of the 40,000 foot oversight. First, you have to realize that this is a big hurricane, but the circulation pattern was one that was particularly detrimental to the city because the winds were such that it blew from east to west across Lake Borgne, which is to the east of New Orleans, and created a surge out of Lake Borgne. And then as the hurricane moved northward, the winds then blew down across Lake Pontchartrain. So you had a second surge coming out of Lake Pontchartrain. It would have been one thing if the levees had stayed there and offered some resistance, and it would have been an overtopping event. Right. But that wasn't what happened. When the surge came in, and it was a massive surge of perhaps 25, 26 feet out of Lake Borgne, that it fundamentally just washed away a lot of the levees. And so there was no resistance whatsoever down in Plaquemine Parish. In New Orleans itself, the primary failure was as a result of the canals. And so that was the second surge coming out of Lake Pontchartrain, and it was coming from the north to the south. When we completed our technical evaluations, getting information from different groups working on the problem, we held public hearings with the citizens of New Orleans, anyone who wanted to speak to us. And so I think we got a great feel for the technical issues, the complications of the technical issues, the political issues, and the human side and the human suffering. The damage could have been a lot less, and it could have been slowed and mitigated over what actually happened. But you know, they started building this levee system back in the 60s when I was working for the Corps of Engineers. The levee boards were not technically competent people. And so you had very inconsistent standards across the levee board jurisdictions. You had some cases where a flood wall would be this high and it would come and then go down like that. And so you had a lot of inconsistent. You had a lot of private levees as well. And some of those were poorly designed. So one of the lessons learned is that you need to have consistency, coordination across your political jurisdictions to get the right product that you need. The other aspect of it was that the system that was built for New Orleans had very little what we call resilience. If one part of it begins to have difficulty, you don't want the whole system to fail. You don't want it to be a zipper effect, that if this fails, the next thing will fail, the next thing will fail. Do it right. It was simply not designed well. And it was not designed recognizing the dangers inherent in the development of the current in New Orleans over quite a long historical period. Clearly, they've built a much more substantial hurricane protection system in New Orleans than the one that was there. New Orleans still needs evacuation plans. It still needs to be very, very diligent about particularly getting people out of the city who are disabled or who are incapacitated and who are poor. The unfortunate fact is that we learn from disasters. And so if you were to look at the East Coast of the United States, how many cities have done a lot as a result of what they saw with Katrina in New Orleans? Not many, not much. The lessons learned are hard for people to, I would say, in other communities to absorb in some cases, because everybody thinks New Orleans is a special case. Now, because we don't have many cities that are built below sea level. New York is very actively doing something about its challenges to respond to what happened in Sandy, and to also, I think they're doing a good job of thinking through the climate change equation and sea level rise. Any city on the East Coast has an issue with the potential hurricanes that we're going to see in the future. The challenge, of course, is partly money. We don't have enough money today to maintain our present infrastructure. much less to say, 10 cities on the East Coast each need $20 billion to build in an infrastructure to protect them from an event that may or may not happen. Engineers have to be in this dialogue because they have to recognize the risk, and they should express this very clearly in public forums. Most politicians are thinking about getting elected 2 years from now, if you will, or the election cycle. But engineers have to think about the long haul. And again, if you're going to invest billions of dollars in a protection system, you probably want it to last for 100 years. And so we have to slow climate change down. That is, we have to reduce the carbon we're putting into the atmosphere, because it will reach a point where you cannot build flood walls high enough to prevent the problems we're going to have with sea level rise. The country as a whole really is not prepared for what the possibilities are, particularly with hurricanes and events of this sort. And it really deserves a national discussion in a rational way to talk about what's really required to protect our cities and how much we want to protect them and against what size events.